My name is Bettina Knote. I'm working in the project Bergische Rohstoffschmiede, which is in English called Bergisch Raw Material Forge, at the Metabolon innovation site, where we are right here located just in front of the visitor center and the conference center. The site is situated in the Bergisches Rheinland region, about 50 kilometers east from Cologne in North Rhine-Westphalia. As a predominantly rural region, it is geographically positioned at the interface between the industrial agglomerations along the River Rhine and the Bergisch city triangle between Wuppertal, Solingen, and Remscheid. Thematically and within the political framework of the North Rhine-Westphalia's sustainability and circularity strategy, the region aims to develop independently and strong based on its own indigenous potential. So, as key part of this regional goal, it is to shift from a linear to a circular strategy for production and economy. In line with the circular economy objective of keeping resources in the production cycle as long as possible, especially small and medium-sized enterprises are challenged to organize their knowledge, skills, and competencies, as well as communication and collaboration with their environment in a smart, constructive and trustworthy manner. And this is the aim of the Bergische Rohstoffschmiede, our project to support small and medium-sized companies in this strategy. So led by the Cologne University of Applied Sciences and the Bergisch Wastewater Association, Bergischer Abfallwirtschaftsverband, our project, Bergische Rohstoffschmiede, develops regional strategies and approaches for training, knowledge transfer and cooperation to promote the circular economy among small and medium-sized enterprises in the region. So over the last 4 years, we have established a framework of research, education and initial expert discussions on circular economy, translating this topic into programs for regional knowledge, skills and competency transfer. So we believe that realizing a circular economy means lifelong learning for all involved actors, from apprentices and employees to business leaders and owners. And under this motto, the Bergische Rohstoffschmiede develops and implements formats for information, knowledge and skill transfer such as workshops, lectures and seminar series, targeting a broad audience of business actors, specialists in the field and young adults as part of their career orientation and vocational training. We also work closely together with our partners from regional and local administrations, political and administrative representatives, such as their departments of economic development, chambers of commerce and interest group of companies. Regarding the aspect of collaboration and cooperation, we aim at increasing awareness and acceptance of the circular economy as a success factor for companies, and we think that to improve circular economy strategies, an extensive cross-sector collaboration between small and medium-sized enterprises as such is essential. So in order to reach this, we say that we have to be aware that transforming corporate processes from linear to a circular production for all involved actors requires fundamental shift in the perspective, not only from concerning one's own products or services, but also regarding to the whole supply chain from the production of raw material to the question how can we recycle and reuse used products. So in these companies we say that companies need to consider all partners along the entire value chain, from the design and raw material selection to production, distribution, return and recycling, reuse. But they have to consider all their, let's say, participants as collaborating partners, not just supply providers. So this means also a shift in understanding what partnership means. So over the past 4 years, we have then developed and coordinating a network for the circular economy in our region, Bergisches Rheinland, because we believe that mutual exchange and the willingness to cooperate are especially important among regional and local political and administrative representatives, the economic development departments, and the interest group of companies and companies themselves. So in the next 1.5 hours we would like to invite you to come with us on a small excursion on the landfill site Leppe, where we, my colleagues and me, would like to introduce you to some very important research and knowledge transfer learning sites in our area. And I would like to start to show you or to give you a little bit an overview about our landfill site. And first of all, I would like to talk a little bit more about the area where we are here. So as I said before, I'm working in the project Bergische Rohstoffschmiede. And the Bergische Rohstoffschmiede is a follow-up project of the very successful metabolon concept, where we are here, and the innovation site of metabolon at a landfill, which is called the Leppe landfill in our region, Bergisches Rheinland. The site was opened to visitors and specialist groups in the year 2010 as a part of a state program which was called Regionale 2010, which also gave the funding for all these buildings, new constructions, research labs, education labs that you will hear about in the next couple of few minutes. Since then, since 2010, large parts of the in some 45 hectare area has been accessible to the public. So we have on the one hand the public area where I am walking right now, and where we will also go up the staircases on the top of our landfill site, but also we have areas areas that serves as waste management center, housing various waste treatment facilities, including combined biogas and composting plant. So now we managed to take the first 40 meters of the in some 110 meter high landfill cone of the metabolon site. And as I said before, we are here on the metabolon innovation site, which in our region and also nationally is a flagship example for transforming a former landfill into a center of innovation, research and knowledge transfer focused on circular economy. Here you can see some of the plants I managed before, the services for the public, such as waste or material from housing restoration. People can deliver here, or you can see parts of the buildings of the biogas plant and the compost plant. As I said before, we have a very broad area, or broad, yes, let's say area of research, which is conducted in cooperation by the Bergischer Abfallwirtschaftsverband and the University of Applied Science in Cologne. And the overarching goal of Metabolon is to conduct research in resource management, environmental technology and circular economy for the region, and also to transfer in cross-sectoral and cross-regional activities of other professional actors. The target, of course, is to effectively transfer the results of all the research and the experiences we do in learning formats and knowledge transfer to other actors in the field of circular economy. But we also aim to raise awareness across a broad spectrum of society actors in civil society as well. This means, for example, also research and education for children from the kindergarten, children to adults, about now the future relevant topics addressed by the project, like a circular economy. So since also at 2010, the research community Metabolon, consisting of Bergischer Abfallwirtschaftsverband, University of Applied Science Cologne, and a lot of other international partners, has been working on strategies to transform linear economies into sustainable circular value chains, where this is the task of our side and also the professional services, where residual materials, as we also have in the content of this cone, are continuously turned into new products or secondary raw materials. We have reached the top of our landfill cone, the metabolon site, which is on 110 meters above the sea. And here you can see, I have a glimpse of the metabolon site, and especially two of the research labs which had been realized in the project of the Bergische Rheinland. As I said before, the research also in these research activities focuses on innovative processes for generating secondary raw material from waste and production residues, as well as their cascading use in material and energy recovery to conserve primary raw material. Especially the research here in those labs focuses on the aspect of plastic recycling and circular construction. Over the years then, an interdisciplinary network of national and international research institutions then had been established, so that we can say that we connect the topics also of plastics recycling and circular construction with a lot of other teams in other areas of Europe and on the world, and discuss them in their respective contexts, regional and economic contexts. In summary, I can say that as part of Metabolon, a comprehensive and stand-outing research infrastructure has been developed at this site. And my colleague from research will tell you more and detailed information later on. What I would like to say is that the entire site has been developed into a teaching landscape. We have several small locations where, as I said before, our target groups, which are children, young adults, apprentices, and those young adults who are in their job orientation phase, can observe and examine the site. And the learning formats of Metabolon offer, in this sense, all age groups a space for experiential learning to raise awareness about environmental, resource, and energy topics. So also for all the formats of the Metabolon Learning Center, which is provided for children from preschool age onwards with numerous hands-on experiments, tasks, and activities, will also be presented by my colleague later on. So in the next step, I would like to show you and introduce you to our exhibition, which also was elaborated in the project Bergische Rohstoffschmiede, which is called From Linear to Circular, where we have models, pieces of the products from various firms and companies out of the region, and to demonstrate their circular strategies and activities also to a broad public. So I hope you will see us in the exhibition. As I said before, our region is characterized by a huge amount of small and medium-sized enterprises in our region in the manufacturing industry. And this is especially in the fields of plastics development and further processing and mechanical engineering. So as part of the Bergische Rohstoffschmiede, we would like to give all these small and medium-sized enterprises already realizing circular activities a face for the public, for the civil society, for professional actors to demonstrate their products and their product pieces to the public. So I would like to invite you to our exhibition room for the exhibition Linear Becomes Circular from Knowledge to Action. And this exhibition is a showcase of circular economy principles in action. But what we did at the beginning was that we outlined very roughly first the our linear production and living circumstances with all those intensive use of raw material, energy, water, trying to give an awareness and a comprehension that we are already in a kind of overload of raw material and resources usage. We demonstrate the Earth Overshoot Day and try then with all these metaphors and pictures to also give younger generations kind of impulse what we at the moment face as concrete problems as regards to our environmental protection and need for protection. And in the second part of our exhibition, we come, as I would say, into the sphere of circular economy. So, and we opened this exhibition in the beginning of 2024, and from then on, visitors the whole day, also on weekends, have the possibility to explore how companies from our region, the Bergisches Rheinland, integrate sustainability into their production processes. And we demonstrate different pieces and products from various firms which highlight innovative approaches, such as the point of durability and repairability of products. For example, with this Kardanschaft for agricultural machinery of one company in our region, where the aspect of durability, high resistance on forces and in the agricultural industry is represented. We also demonstrate pieces which demonstrate a very smart use of secondary raw material. For example, if we take this kind of brick from a firm also in our region, they worked also together with the Technical University Cologne on the construction of bricks, where the layer of the bricks, instead of being produced with cement, the layer is produced with alternative mineral binders, which their production of the binders releases less CO2 emissions than the cement. A third principle is the recycling and reuse strategies incorporated from the very beginning of the value chain. And I would like to demonstrate two pieces, two products. On the one side is packaging, for example, for the food industry, which is made of the alternative raw material of grass. And this is a very interesting example of our region from a firm who produces packaging for food, but also packaging for presents, postcards, paper out of grass, out of cooperations with NGOs and other organizations who also are very active on the one hand in moorland restoration, where they gather
then a certain kind of grass, which is very convenient for the grass production, and also locate this cooperation in the aspect or in the whole political and environmental field of biodiversity protection. So this is a very interesting example of using a completely alternative raw material and doing cooperation along the value chain of paper, but also the cooperation with surrounding actors in order to also politically and strategically foster environmental protection. The second example for recycling and reuse strategy I would like to demonstrate on a firm which is producing bicycle tires, and they developed a whole circular business model for the production of bicycle tires from the production itself with primary raw material, the recollection of the used bicycle tires in cooperation with all those bicycle shops all over Germany and in cooperation with a logistic partner, then processing the used material into recyclable secondary raw material, which is the so-called recovered carbon black, and then transfer 80% recycled carbon black into new bicycle tires, which is really a very big share. As you may already realized, this table is our central part of the exhibition. It's an interactive tool where people, interested visitors, can select the number of the product they would like to learn more, giving the number into this tablet, and then it is possible for the whole value chain from product design, producing, usage, collection and recycling to follow the whole path of the product in its value chain by small little texts and pictures. In general, I would like to show you also what we described and presented as regards to our site, the landfill site of Metabolon. Visitors can, for different topics, see films or can hear small original tones, like what in general means Metabolon, which means the transformation from a landfill site to an innovation site. What's about the research environment of Metabolon with all its national and international partners? What are formats for the learning and in the learning center, didactical center? What are the main topics at Metabolon as regards to energy, resource management, sustainable construction, and also which are possibilities then for leisure time here on the site for the civil society. Here then we have a demonstration on which substances the teams of the TH Köln, also University of Applied Sciences Köln, are working on as regards to the plastic recycling, as regards to the recycling of combined material, as regards to what we also have on landfill sites, such as gases and water, and how can we use those gases extracted from the landfill site for producing energy. And we have the whole process of what I already described with the recycling of the bicycle tires, the whole recycling process of the pyrolyse recycling methodology as regards to the different materials from this technique that evolve in the pyrolyse process, like as the gas, the pyrolyse oil, and as I said before, the carbon black, which then is used to produce secondary raw material for rubber construction for the rubber ingredients, let's say, for example, for new bicycle tires. And last but not least, we also have a small showcase then for our project Bergische Rohstoffschmiede. Our working fields, our partners, what do we do, initial actors or expert discussions, as I said before, seminars, workshops with our partners in the region and from the commercial side, and a summary also about, in general, the research strategy on our side, innovation side, Metabolon, together with the University of Applied Science, Cologne, with this international didactical and research center here in Metabolon in Lindlar.
So, as part of the Bergische Rohstoffschmiede project, 2 model houses were created as examples for sustainable, self-constructed tiny houses. We are here standing in front of one of the tiny houses, so-called real-world laboratories for circular construction. And we were very happy that these houses, which had been developed within the project by a team of the University of Applied Sciences of the TH Köln, received an award, the German Solar Prize Award in the category Education and Training in 2024.
And welcome to this quick tour of the tiny house in which I've been living for the past 2 months. Please come in. So let me close the door. It's very windy out here. Yeah, so basically that is my living room, and as a matter of fact the only room really. This part is built in a room way, which means that there's one big room which is separated into different kinds of living spaces. So if you follow around this corner, you can see the toilet really is the only closed off room. Then we have the kitchen up there, that's the working space, and all the way up there, the very roof, is where I sleep. And yeah, basically that's where I've been spending the last 3 months in this beautiful kind of nature. If you come outside, you will see that vegetation grew over, summer's coming, so everything is green.
This house and all the activities on the Metabolon side that I was demonstrating you in the last minutes are part of a broader political action plan on circular economy initiated by the state government of North Rhine-Westphalia. A key element of this action is the Roundtable for Circular Economy for North Rhine-Westphalia.
This illustration demonstrates the administrative and organizational structure of the Roundtable Circular Economy for North Rhine-Westphalia. There is an overall leading board with, on the one hand, the steering group and a professional council. Members of the steering group are the 2 ministries, the Ministry of the Environment, Nature Conservation and Transport of the state of North Rhine-Westphalia, and the Ministry of Economic Affairs, Industry, Climate Action and Energy, as well of North Rhine-Westphalia. Then we have the 2 organizations, NRW, Energy for Climate, which is a state company for energy and climate protection, and Metabolon. The professional council consists of various actors also from North Rhine-Westphalia region, which are funded or commissioned by both ministries, and they accompany the roundtable with professional and technical support. The main or the very important group, of course, are the members of the networks. Here we have actors from various associations, organizations, universities and projects, and they all committed themselves to one condition for membership, which is the commitment to the Charter of the Network Circular Economy North Rhine-Westphalia. Also in this group of members of the network, we have the already mentioned thematic tables, where it is free to join and to work together to various topics, as for example circular construction, circular electronics, circular food economy, circular companies, digitalization and circular economy, circular textile production, tire recycling, or circular metal industry.
In integrating the activities here in North Rhine-Westphalia and in the regional areas in the frame of the European Green Deal, we also follow the overarching goal to make the economy and the society climate neutral by 2050 and to decouple, this is so important, economic growth from resource consumption. And a central pillar of the European Green Deal is the Circular Economy Action Plan, as we also have one in North Rhine-Westphalia, which both consider the entire product life cycle and promotes the circular use of materials to enable sustainable value creation. And this is what we like to show and to demonstrate also on our landfill side in the exhibition, trying to connect in the research activities and the educational formats. But back to the roundtable for circular economy for North Rhine-Westphalia, the network fosters collaboration, especially collaboration and communication among stakeholders from industry, research, politics and other sectors to together, jointly, shape the transition towards a circular economy in North Rhine-Westphalia. The initiative is led by the Ministry of Environment, Nature Conservation and Transport, as well as the Ministry of Economic Affairs, Industry, Climate Action and Energy of North Rhine-Westphalia, and in cooperation with Metabolon. We have an advisory board in the roundtable composed of key partners from within the network, and this advisory board provides thematic guidance and facilitates the dialogue among the actors through specialized working groups. These specialized working groups we are calling thematic groups. They focus on core areas of circular economy with the aim to develop a unified statewide strategy on circular economy in North Rhine-Westphalia. So on the one hand, the network aims at communicate new insights in research, new experiences in didactical work for a circular economy among all relevant professional actors in North Rhine-Westphalia. But secondly, also the whole environment of the roundtable also feed their knowledge and their competencies into both regional and national programs, such as on national level into the Germany's National Circular Economy Strategy. So that means that it's not only the exchange of experiences, but it is also the transfer of knowledge and experiences into the national and regional political lead programs. Participants in the roundtable represent a wide range of perspectives from across the value chain. The objective then is to promote the political, strategically impact of the network, but also to focus on certain thematic, specialized thematic fields. And the current thematical work groups then and fields include the topics of construction, circular cities, electronics, food industry, furniture, recycling of biogenic resources and textiles. And the participation in all these working groups is open to all members of the networks. So this was a short introduction into our work on the Metabolon landfill site and the Metabolon Institute and all our activities also in the project of Bergische Rohstoffschmiede. And thank you very much for following me on this small excursion. In the next speeches and presentations we would like to go deeper into two main working fields here on our side, which is the didactical framework and the didactical offer of Metabolon and the research conducted by the University of Applied Science in Köln. So stay tuned.
The easiest time for change is at a young age, and to accompany that we have an extracurricular learning side, My name is Mark Hertkon. I'm the coordinator of this site, and from now on we will show you a little bit an expression of what we do for the kids. The site itself offers a large opportunity to explore and learn, but in addition to that we have a wide variety of modules for educational organizations that they can choose from. It starts in the kindergarten with the older preschool kids up to the bigger students from schools, primary schools and also the secondary schools. All those topics are site related and are a mixture of exploring with the hands, using different senses, and also doing some research and getting to know better what we've seen during our guided tours. So we will have a short visitation for some of the topics. We can't show all of them, but at least we will show you some of them. In small groups, the students repeat and deepen the topics that they've visited and seen during the guided tours. For example, our waste treatment for bio waste, for paper waste. They try to get the right cycles. For example, how would you offer, what would you do with the bio waste at home? You can throw it in the bin or use the compost if you have one. Both produce soil that can be then used to plant trees, flowers and other stuff. Similar, we're doing the same thing for the paper waste cycle, but we don't end at the waste part, we also try to avoid waste, and that also on topics that are really common for everyday life, like shopping, for example, in the leper shop. There, even the smallest children can try to look for the most environmental friendly product in each category. For example, orange juice, cheese or apples. Sometimes the small visitors also get their hand dirty, like Indiana Jones looking for old treasures. In our case, it's more waste that is hidden in the soil. For example, like this can, which is laying here since 2 years. The project location with its diverse collaborations offers a wide array of projects that can be realized, and some of them grow even bigger than we thought they would be. So one example are these boxes. The topic is plastic and microplastic. It started as a collaboration with the Technological University Cologne, where we started doing a little project day for schools around the topic plastic, microplastic. From there on, we developed one of our modules that is the most frequently asked, and later on we also did an evaluation, and later on we developed 3 kinds of suitcases that are all focused on this topic. We started for our region, but now they're available throughout all of Germany, and also some of them are also in Austria. But there was no option to do this all alone, so we used our collaborations with the Rotary clubs in developing it and also getting a certificate for them. We combine digital interactions together with practical experiments in the lab part. Some of these experiments we will show you now. The MINT lab focuses a group of older students, usually class 9 and older, and here we're in the STEM category. So we're mainly focusing on technological topics around energy supply, sustainability, mobility, and also with a focus on study and career orientation, all along with the skills that are necessary for sustainable development. The topics range from solar power, wind power, over climate change. We combine digital interactions together with practical experiments in the lab part. Some of these experiments we will show you now.
Hello, my name is Himanshu. I work at Metabolon as a circular bioeconomy researcher and as a EU grant manager. In terms of circular bioeconomy, I'm mainly dealing with how we can take organic waste and recover energy out of it. So in Germany, the typical thing is the households will collect their organic waste separately in a brown colored bin. Then this bin is collected by the municipal trucks and it's brought to Metabolon. And there we have an industrial scale biogas plant which is used to produce biogas. This is a very standard process. However, what we want to do, we want to make the process even better. We want to improve it even further. So at this moment, what we are testing in lab is this experimental setup. And what's happening basically here is we are doing the test in 1 liter reactors. You fill these reactors with organic waste and our inoculum, so that is our microorganisms, and the microorganisms start to eat it, and as a byproduct they produce biogas, which will be, let's say, roughly 50% methane and 50% carbon dioxide. Now, if we want to put this methane or this biogas into the gas grid, it's essential to upgrade it. So what we have to do is we need to remove the carbon dioxide out, and that costs a lot of money and a lot of energy because it's not so easy to separate the gases. So what we are going to test now is we want to test MEC, so microbial electrochemical cells, and the main aim of this reactor is to improve the concentration of methane in the biogas. And to put it simply, how it happens is we put electrodes, as you can see here. They can be made up of different substances. We put it there, fill our reactor with microorganisms, our inoculum with also with the organic waste. We apply a little bit of current, as you can see here from outside, and then an added set of bacteria that are called electroactive bacteria. They convert the carbon dioxide that was produced in the previous process to methane. And when this process goes well, we can get up to 90% methane in a typical gas mixture. So when you do normal anaerobic digestion, it will be 50% carbon dioxide, 50% methane. When we apply the MEC system, then we get only 10% carbon dioxide and 90% methane.
Hi, my name is Manuel Vasquez. I'm here in Metabolon doing my internship and this is part of my internship project that is upgrading this reactor system to a MEC AD system. And the most important features of the system is that we need to mix and heat the material that we put inside. Here we are testing with water. Also, I already tuned with a PID controller the heaters, and here it's a display of all the data. As well, I made a new code that it's working well, and here it's another set that we are still tuning.
My name is Alex. I'm scientific co-worker here at Metabolon Institute, and I'm especially concentrating on the work with microalgae and bacteria for the treatment of landfill emissions. So at a municipal landfill site we have especially two kinds of emissions. The first one is landfill leachate, of which we are producing around 100 to 200,000 cubic meter each year. And these landfill leachates are highly nutrients contaminated, especially with ammonia and organic carbon. And they need to be treated because if they are getting into the environment without treatment, they pose serious environmental problems like eutrophication or the toxification of ground and drinking water. So the second big emissions at municipal landfills, like the landfill in Leppen here, are landfill gases. So landfill gases contain huge amounts of methane and can be used for electricity production. And at this site here, for example, around 10 million cubic meters are produced every year. However, with increasing age of the landfills, the methane contents are decreasing. And if the methane content is lower than 40%, it cannot be used for electricity production in a power plant, for example, anymore. So in this case, it has to be treated. So in the symbiotic process of microalgae and bacteria, we can use sunlight, the nutrients from the wastewater, and the CO2 from the landfill gas to produce valuable biomass. And by harvesting this biomass, we can extract the nutrients and the CO2 from this process and store it inside of the microalgal bacterial biomass, which we can harvest from our photobioreactor. Here we see a suspension culture of the microalgae bacteria symbiosis, and over here we have built up around 400 liter pilot plant where the microalgae are growing on so-called light guiding plates, and by that we are able to increase the surface of the light availability inside of the process heavily. So in this project here, we are cultivating microalgae to investigate the uptake of CO2 from landfill gases in the microalgae biomass. The system is not completed yet, but therefore we have, like here are the growing microalgae, and here we have external gas exchange. So we potentially could scale this easily up by just integrating a gas exchange chamber to a bigger photobioreactor.
Hello, my name is Martin Bruns and I'm working at Metabolon to separate algae from the reactor from Alex, and I'm using different techniques to separate algae like this, like getting the clear, and here I'm getting the concentrated volume of the algae, and this is like the start. I'm using mechanical separation, like some hydrocyclones where you put the algae in, and it's separated by the centrifugal force. We are also testing some electrochemical systems to get these results and combine these two techniques together. There are already some processes to separate the algae, but most of them need high energy right now, and this makes 20 to 30% of the cost of the whole process, and that's why it's important to make this step more effective. And also there's just a tiny bit of algae, like 99% is water and the rest 1% is algae. Also these particles are very, very small, and the density is very close to water, which makes it very complicated to separate.
Hello, I'm Lennart, and I'm currently writing my bachelor thesis here at Metabolon, and I will show you just briefly what my project is all about. So as mentioned before, we are growing algae as a part of water treatment process, and my thesis starts where the process of water treatment ends, which means with the biomass, which is most popularly used to produce biofuels. But I'm looking at the opportunity of transforming this harvested biomass into a biopolymer, and I can show you briefly through the steps that we are currently researching on. So we are harvesting the biomass, and in the process of drying we end up with this kind of dry biomass, which is then further polymerized into PLA. And this PLA can be furthermore used to produce any kind of plastic application, such as this filament, which is currently used for 3D printing. And this is just a very, very, very brief overview of all the research that I've been doing here. But basically it's optimizing and tweaking this process into perfection. Thank you.
This is our third research hall, the Center for Processing of Biomass. Next to mechanical processing steps such as shredding, sieving, there's a focus on hydrothermal carbonization. Here, wet biomass can, under high pressure and high temperatures, pressures around 30 bar and temperatures beyond 200 degrees Celsius, can be turned into valuable biochars. Ideally, if this process is conducted correctly, the wet fraction, separate from the biochar, contains most of the contaminants, so that the biochar is pure. Welcome to our fourth research hall. This is the Thermochemical Center. And here on your right-hand side, you can see our pilot-scale pyrolysis oven. And on your left-hand side, the pilot-scale gasification plant. Pyrolysis is the process of thermal degradation at very high temperatures. We're talking about temperatures of 600 to 700 degrees Celsius. And our research has shown that pyrolysis is excellent at degrading rubber composite parts, with the coke, the resulting coke, being a good raw material for the manufacturing, specifically the coloring of new tires, and thus it can be reintroduced back into the cycle. Another advantage is that the resulting pyrolysis gas, depending on the process parameters, can contain significant amounts of oxygen, which also can be further used. In contrast to the pyrolysis, which takes place in anaerobic conditions, the gasification, which takes place in the gasification plant, uses a limited amount of oxygen for its thermal degradation. And here biomass can be degraded to a very energy-rich gas, and also carbon that can be further used as activated carbon.
Here we have the ferrohydrogen tunnel, where we can separate hydrogen out of a mixed gas in high purity contents. The principle is a membrane principle, where we separate the hydrogen over a pure iron membrane to further increase the purity and use it in hydrogen-only applications. The experimental plant is located here in our research facility, and is currently in use to try to implement the separation and the production of syngas and hydrogen in all of its aspects.
As you might know, we are rapidly running out of filler materials for concrete, such as sand and gravel, and must look to new sources that can replace the sand and gravel. This can either be construction waste reuse or the ashes from incinerator plants, from waste incinerator plants. Whether the waste incineration ashes or construction waste is to be used as alternative filler materials for concrete, prior processing steps always have to take place. And this happens here in our 5th research hall, the Center for Mechanical Processing. And the processes that take place here are, among these processes, sieving, granulation, fractioning, and separation. So as a result, dependent on the input stream, you get output ordered by size, as you can see here. Because size is one of the main influencing factors on the concrete characteristics. These waste incinerator ashes, as you can see here behind me, bring with them suitable characteristics for concrete manufacturing. However, residual contaminations such as heavy metals are problematic in actual use for construction.